This video is about v versus t graph. So when we write v and then in brackets t, that tells you that this is a function that depends on time, but that function is v for speed or velocity. So that will show us how velocity changes with time. And as opposed to x versus t, so let me create a graph that will run parallel to it, but it will be x versus t, and we will compare them so that you see the difference. So see them side by side. One is x in meters versus t in seconds, and that's x versus t. And the one on the left is v versus t. V in meters per second, time in seconds. If we have a flat graph on both, what does that mean? So the one on the right, the pink graph, is flat. It would know that this would be rest. And we know that because the velocity is 0. There is no slope. X versus t shows us that x, which is position, does not change with time. However, the graph on the left, the red one, that is not rest, even though it's flat. What this means that this velocity is 10 meters per second in the positive direction, whichever that might be, and it is not changing. So this part is constant velocity in one direction. Nothing is changing. Now look at the next pair. The one on the right, the green graph, shows us that the objects started at what would be 4 meters away from whatever our point of reference 0 was. Maybe house, maybe school, maybe bus stop, whatever. So it started at 4, and then it started moving. Now let's consider another set of graphs. Here we have negative slope in both of them, but it means very different things for these two motions. So we'll start with the one on the right, the green graph. It shows us a negative velocity, meaning that we're going in the opposite direction of what we consider positive. So let's say positive is east, then this is west. So the object is moving in the direction of west. And how fast is it moving? Well, if we look at, we can choose any point. So I'm going to look at from 0 to 4 seconds. What happened? Our final position at 4 seconds is 0. Our initial was 12. So 0 minus 12 over 4 is -3. And what did we do? We divided meters by seconds. Rise over run. Rise was in meters. Run was in seconds. So that's just from the graph. And then velocity formula is change in x over change in t. The same thing. 0 minus 12 over 4. -3 meters per second. Either way, rise over run or just the formula will give you the same. And now what happens right here where we cross the t axis? Well, we just passed something. Whatever our point of reference, which we marked with a 0 was, we passed it and then we keep going. Nothing really interesting happened. We just passed whatever we considered our point of reference of 0 to be. Now on the left, that's a totally different story. So this we can split into two parts. So this point right here now matters a great deal, because this part from 12 to 0, this is where our object is slowing down. Acceleration is change in v over change in t. Now, how did our velocity change? We went from 12 to 0, so final 0, initial 12 over 4 seconds. That's -3 meters per second squared. Kind of makes sense. It's a negative acceleration, so we're slowing down. Okay. However, we then continue with that negative acceleration down below. What does that mean for us? It's the same acceleration, still -3 meters per second squared, because it's the same slope. But what does it mean in terms of speed? Is it speeding up, slowing down? Well, let's see. So this would be -12. So again, acceleration to -12 from 0 in 4 seconds. That's -3 meters per second squared. But remember, -12 just means that, as far as velocity goes, -12 meters per second just means that the object is moving in the opposite direction, in the negative, so to speak, direction. But 12 meters per second is a pretty hefty speed. So even though it's a negative acceleration, it could also mean that the object is speeding up. Now, speeding up versus slowing down. Speeding up means that our V's are going either into more negative or into more positive. I'm just going to add, so if I were to add a positive acceleration over here, this would also mean speeding up, but only in the positive direction. So this is speeding up, and that's speeding up as well. So this one is also speeding up. So this would be how you read v versus t, or v of t, or velocity versus time graph compared to x versus t graph. They might look the same, but they mean very different things.